So we're doing a unit on exponential equations. What is an exponential equation anyway? What makes it exponential? By the way, everything that has an exponent is not exponential. That's not an exponential equation. It has an exponent, but that's not an exponential equation. So, what is an exponential equation? I wrote it down this way yesterday. That's an exponential equation. Where is the x? Where's the variable x? That's the exponent. It's an exponential equation when the exponent is a variable. And do you remember what the A stood for? The initial or the starting amount. And do you remember what B stood for? The multiplier is called a growth factor or a decay factor. So, do we have different equations today? Not really. They're just more specific. And so, write your exponential growth equation down and write your exponential decay equation down. This is the equation that I gave you yesterday. These are the two equations we're going to look at today. They're not different equations. This is just more specific. If you have one representing 100% all of something, and then you add the rate to it, this number is going to be bigger than 1. If you have a base number here that's bigger than 1, you're going to have a growth equation. If you take 100% and subtract something from it, this number is going to be less than 1. If your multiplier is less than 1, you're not going to have numbers that are getting bigger. You're going to have numbers that are getting smaller. They are decreasing or decay. And so these are just more specific. It's not a different equation. It's just more specific. So you need to be sure to write this down. Let me move this for a minute. If this number right here is bigger than 1, then you have growth. If this number right here is less than 1, then you have decay, and decay means it's going to be decreasing. So add that to your equations, your formulas. If the base number is bigger than 1, it has a growth equation. If your base number is less than 1, it's a decay equation. Now, as I told you yesterday, I like this unit because there's all kinds of real-life applications of this type of problem. If you put your money in a bank in a savings account, do you know that you would expect the money to increase in the savings account? Because the bank will pay you interest for putting your money in the bank. Did you know that's what they did? For a savings account. So, if we have, in the exponential function below, it models the amount of money in Jose's savings account where X represents the number of years since he invested the money. Now, I suppose you don't want to write all of that down. So, I'm going to tell you the important part that you need to write down. You need to write down the word savings account so you can have some context for the problem. And then you need to write down the equation. So this is a savings account. Savings account earn interest. So here's the equation. This is representing a savings account. What do you think that $3,000 represents? How much you put in the account to begin with. Okay, so write this part down. $3,000 is the initial amount in the savings account. He opened the account with $3,000. Our next question is, what is the growth rate? And I need to point out that whenever we use the word rate, we're talking about a percent. This number right here is the growth factor. It's not the growth rate, and the reason I'm emphasizing that is it's real easy to get those mixed up. The growth factor is a number. The growth rate is also a number, but it's a percent number. And that's the R in the equation. It's the rate. All right, well, if this is the growth factor, what's the rate? Do you see that the 1.06 is at the same place in the equation as the 1 plus R? So how do I get just the rate without the 1? Subtract the 1 from both sides. And so then this would be 0.06 is equal to R, and R stands for the word rate. So the growth rate is 0.06. But we always talk about the growth rate not as a decimal, but as a percent. How do I change this decimal number into a percent? The reason you move your decimal 2 places is because the word percent means part out of 100. And if you multiply by 100, that moves the decimal place over. So the growth rate is 6%. The growth factor is 1.06. The growth rate is 6%. And it's real easy to get those mixed up. By the way, that is not reasonable for the banks at this time. Banks at this time are paying more like 1% interest on a savings account, maybe 1.2. Okay. Second example, the cost of tuition at a state college is $8,500 and is increasing by 3% each year. I'm not sure what the current rates are. I'm not sure if this data is current or if it's out of date. A state college would not be something like San Jac. San Jac would be a local college. A state college is something like Stephen F. Austin University or Sam Houston University or even the University of Houston. Those would be what we call state colleges. And it's increased. Now this is, I think, accurate. The cost of tuition is increasing by 3% each year. What is the tuition after 6 years? Well, here's the important information. Let's write this word down so we have some context. That's the tuition. Okay, that's the important information, so you don't have to write down the whole sentence there. You can if you want to. Okay, so the cost of tuition is that much. It's increasing by 3% per year. This word increasing tells me that I'm going to use the growth equation, because I'm going to need to look for a key word to tell me in the problems that you're going to have for your homework. Am I supposed to be using a growth equation or a decay equation? So this word right here tells me growth equation. Now, that's this equation right here. What did the R stand for? Rate, percentage rate. But I cannot use a percent in this equation. Whenever I have a percent, I need to change it to a decimal in order to put it in the equation. The equation has to have a decimal rate, not a percent. Do you know how you change this to a percent? Percent means part out of 100. 3% is equal to 3 over 100. So you can put that in your calculator if you don't already know that this would be 0.03. The way you change a percent to a decimal is you divide it by 100, because the word percent means part out of 100. Okay, so now we're going to use our equation up here. Here's the equation. What does the A stand for? Initial amount. How much is the initial amount of the college? One plus the rate. T stands for the time. Yes, and so what is the cost after 6 years? 8500. You can leave it just like that, or you can go ahead and add those together. It doesn't matter. Either way, you will get the same answer when you put your equation into Desmos. We put the 6 there because it specifically asks what is the tuition after 6 years. Hopefully it won't take you 6 years to get through college, but if it did, put that in your Desmos and tell me what the answer is. No. If you were using Desmos, when you are using Desmos, this is what you put into your calculator. 8500, 1.03. Do you remember how to raise it to a power? Shift 6, or the keyboard, 10149.44. Now, how did I know to put 2 decimal places? Okay, and so how did I know 2 decimal places? It's money. Money has 2 decimals. Okay, so Sally deposits $10,000 into a savings account that pays that much interest. What is the balance after 5 years? Now, you can see that I put up here next to this problem a growth equation, but how did I know it was a growth equation? Because on your homework problems, you're not going to have the growth equation sitting up there. You're going to have to decide for yourself whether it's growth or decay. Well, this is a common knowledge kind of thing, which you might not have because you might not have a savings account yet. So savings account pay you interest. So when you have a savings account, after 5 years, you would hope to have more money than you started with. So whenever you have a percent, the first thing you do is divide the percent by 100. percent means part of 100, divide it by 100 so that you can have the decimal number. Because this rate right here has to be a decimal number. Okay, the equation. A is the initial amount. How much did we start with? 1 plus the rate we just figured out. The equation has t for time. So, what was our time? 1. You can add those together, or you can just leave it with the plus line. Desmos doesn't care. We're going to raise it to the 5th power because it says after 5 years. Two, 5, 8. This is money. Money has 2 decimal places. And so I rounded it off to 2 decimal places. Okay, this problem is an exponential decay problem because it says so right there. But if I didn't already have this up here, how would you know that this is an exponential decay problem? Well, let's read the problem. The exponential function models the value of Melissa's car, where x represents the number of years since she purchased the car. So, write that word down so we know what this equation is representing. What does the 28,000 represent? The initial value of the car is, or was, that's how much the car was when she bought it. What happens to the value of cars over time? 5 years later, is it still going to be worth $28,000? You know what happens to the value of cars? They go down, with one exception, which would be classic cars. Certain models of old cars are considered very valuable and their price goes up. But most cars, their price goes down. So, what is the rate of decay? What does the word rate mean? Whenever you see the word rate, you need to answer in percent form. This number right here is less than 1. That's how I know this is a decay problem. This number right here is equal to this part of the equation. 0.86 equals 1 minus the rate. I'm solving for the rate, so I subtract 1 from both sides. What do you get when you subtract 1 from both sides? What's 0.86 minus 1? What? Is that what you got? If you take 0.86 and subtract 1, that's what you get, and that's equal to negative r. Divide both sides by negative 1, and that will cancel out the negatives, and so the rate is negative 14. But rate means what? Percent. How do you change that to a percent? To change a decimal to a percent, you multiply by 100. That moves the decimal point over 2 spaces. That is 14%. That is a reasonable amount. Most cars decrease in value between 10 and 15%, depending on what kind of car it is. Okay, so a student population at a local high school is 1375. It's decreasing. This word right here tells me I have to use a decay equation. It is decreasing by 2% per year. So, we have a student population that much decreasing by 2%. That's the critical information. Now I need an equation. Oh, but first, whenever I have a percent, I need to change it to a decimal. If you do that first, then you won't forget to do that. Okay, so what's the equation going to be? How much do we start with? Since this is decreasing, I use the decay equation. You can use this just like that and raise it to what power? 7. Or you can write it that way. Either way will get you the same answer. When you put it in your calculator, did you get 1193 point something students at the high school after 7 years? And again, we round to whole numbers because students can't be decimal people. Okay, so often biology people use this kind of equation because populations can increase or decrease. So we have 400 animals decreasing 4 years. The word decreasing is the clue that I am supposed to be using a decay equation. The first thing you do when you have a decimal is change your decimal. I'm sorry, I said it the other way. When you have a percent, change it to a decimal. Whenever you have a percent, change it to a decimal because I need the decimal for the equation. How many species just means some kind of animal. How many animals do I have to start with? Somebody went out there in the woods and counted up 400 animals. There's a minus sign here because this is a decreasing population. And how many years? 4 years. So that is what you put in your calculator or in your Desmos. How many animals am I going to have after 4 years? There's not decimal animals, so you would round it to a whole number. So, if you wanted to be an overachiever, you would write the answer in a complete sentence. After 4 years, there will be 305 animals left. The growth rate is a percent. You have to take that growth factor, subtract 1, and times it by 100 if it is asking for the growth rate from the equation. If it's asking for the decay rate, you have to do 1 minus the decay factor times 100 to change it into a percent. Growth equation, exponential equation. What's the only difference? Whether it's a plus sign or a minus sign. If this number is bigger than 1, you have a growth equation. If this number is less than 1, you have a decay equation.